Welcome. In this video, we're going to take a look at some limiting excess reactant problems and how to determine how much of the excess reactant is left over. And there are several different approaches you might take to this, so I'm just going to show one approach, and it's fine if you do it a different way. So here's an example. I've got 4.2 moles of zinc sulfide and 6.8 moles of oxygen. They react according to this balanced chemical equation right here. And we want to figure out how much of the excess reactant is left over when these two things completely react. So first thing we want to do is figure out which reactant is limiting and which is excess. So what we're going to do here is I'm going to do two side-by-side stoic problems. So one, I'm going to start with 4.2 moles of zinc sulfide, and then one I'm going to start with 6.8 moles of oxygen. And I want to compare how much product would be made if this reacts completely. And I've got two products to choose from. It doesn't matter which product I choose to compare. I just want to pick one. So I'm just going to look at zinc oxide just because. I could have chosen SO2 as well. That's fine too. But I'm going to go with zinc oxide. So I'm going to say, okay, for every 2 zinc sulfides, I can make 2 zinc oxides. So it looks like I have enough zinc sulfide to make 4.2 moles of zinc oxide. And if I do this for oxygen, it looks like I need 3 oxygens to make 2 zinc oxides. So if I go and plug that in my calculator, 6.8 times 2 divided by 3, I end up with 4.5 moles of zinc oxide. I'm rounding this to 2 sig figs here. And so it looks like this one is, less. Okay, this is a smaller number. 4.2 is smaller than 4.5. So that means that my zinc sulfide must be my limiting reactant, which means my oxygen is in excess. Okay, so part one done. We've identified who the excess reactant is. Now I need to figure out, well, how much excess oxygen am I going to have at the end? So there's a couple different approaches to this one. One way in which you could do it is you could say, well, I know that 4.2 moles of zinc oxide are going to be made in this reaction. So then you could say, well, how much oxygen would get used up in the process of making 4.2 moles of zinc oxide? So for every 2 moles of zinc oxide, I'm going to use up 3 moles of oxygen. So if I stop and I plug that in, 4.2 times 3 divided by 2, I get 6.3. And so I think about what this number represents. So this represents there's 6.3 moles of oxygen will be used up in the reaction. So I haven't answered my question yet. My question is how much oxygen will be left over. So I need to go back here and look and say, okay, at the beginning, I had 6.8 moles of oxygen at the beginning before the reaction, and then 6.3 moles of oxygen are, used up. So what I'm trying to figure out is how much is left over. That's going to be 0.5. So this is the answer to my question, how much excess reactant is there? There's going to be 0.5 moles of excess oxygen kind of hanging out in the container once this reaction is complete. All right, let's take a look at one more problem like this. This is a similar idea. It'll take us a little bit longer though, because we're doing grams to grams instead of moles to moles. All right, so we've got a mixture of these two reactants. Okay, so we've got 32 grams of S8, and we've got 71 grams of Cl2, and you're going to try and figure out how much product S2Cl2 is made. So I'm given values for each reactant. So this looks like a limiting excess reactant problem. So since I have 2 values, I need to do 2 stoic problems. So first thing I'm going to do is I'm going to convert grams to moles. So if you look at your periodic table, 1 mole, and actually I already wrote it right there, 1 mole of S8 is 256 grams. And then we use my mole ratio. So every stoic problem should have a mole ratio step in there where you're considering the coefficients from the chemical equation. If you are not considering the coefficients here, then it'd be kind of like cooking without looking at your recipe. So you'd be doing it wrong there. So make sure you've got a mole ratio step involved. And then every 1 mole of S2Cl2 weighs 135 grams. Okay. And so you can stop and solve there. And let's set up the next one first, though. So for Cl2, this is about a mole of Cl2 because 1 mole of Cl2 weighs about 71 grams. Okay. And then I need 4 Cl2s for every 4 S2Cl2s. So it's a 4-to-4 ratio. Getting that from the coefficients in your balanced chemical equation. And then if you look on the periodic table, you can find the mole to grams conversion. Okay. So if you plug this in your calculator, times 4 times 135. So basically you're making, up here, you're making like half a mole of your product. And down here, this is basically, you end up making basically a mole of your product here. So this one makes less product, right? So that means that S8 is the limiting reactant, which means that your Cl2 is going to be in excess. So if we answer these first two questions, who's the limiting reactant? It's S8. How much product are we going to make? It's 67.5 grams, and our supporting work is shown below. And then that last question is how much excess remains? So I'm going to go to the next slide so I have a little more room here. So if we're trying to figure out how much excess remains, one way of doing that is I could say, well, I know this is how much product we make. We make 67.4. It looks like if I'm being a little more precise. So we made 67.4 grams of product. And what we can do is we can work our way backwards and figure out how much Cl2 was used up in the process. So this is how much SCl2, and it looks like 1 mole of S2Cl2 is 135 grams. And then I want to figure out how much Cl2 was used up. So I'm going to go from, I'm going to use this ratio that for every 4 S2Cl2s, we need 4 chlorines. And then I want to figure out how many grams of chlorine were used up. So for every 1 chlorine weighs, 70.9 grams here. So if I stop and plug this in my calculator, 135 times 79, I end up that I've used, 35.45 grams of Cl2. So this is how much grams of Cl2 were, used up in order to make the product. Okay. So I still haven't answered the question yet. The question says, how much excess remains? So I'm going to do this in a different color here. So what we say is initially we had 71.0 grams of Cl2 at the beginning. Okay. And then we used up 35.45 grams, is used up. So what's going to be left over? It's going to be about 35.4. Let's see. It's 35.55, I guess. Okay. So you're going to have 35.55 grams of Cl2 remaining. Oop. And yeah, and again, there's more than one way to, approach this problem, but this is just one way you can think about it. All right. And let me know what follow-up questions you have.